This screencast is about Chapter 4, Part 1. And we're going to start taking a look at exponents. So in number 1, we are going to simplify each exponential expression. In Part A, we have 2 to the 4th power. So 2 to the 4th power is the same thing as saying 2 times 2 times 2 times 2. So we can add that up and we would get 16. So 2 to the 4th power is 16. Part C, we're taking 25 to the 3rd power, which is 25 times 25 times 25, which will give us 15,625. So it says in Part C, what number is the base? So if we take a look at letter C, our base is going to be our 25. So 25 is the base, and then the number that's the exponent is the number that's written as the superscript. So it's up in the top right corner. So that number is going to be a 3. In number 2, we are going to rewrite in factored form and then simplified exponential form. So for the first one, we have 5 squared times 5 to the 5th. So we can rewrite that as 5 times 5. So that represents 5 squared, it's 2 5s. And then 1, 2, 3, 4, 5 more 5s. So we have the 2 5s for 5 squared, and then the 5 5s for 5 to the 5th power. So we have a total of 7 5s. So we could rewrite it as 5 to the 7th power. For the second example, we have 3 cubed times 3 squared times 3. So we'll have our 3 times 3 times 3 for our 3 squared, for 3 cubed, 3 times 3 for the 3 squared, and then times 3 for the 3 that's left over. So we have a total of 6 3s. So it's going to be 3 to the 6th power. Next example, x cubed times x to the 5th. So it's going to be x times x times x, and then x times x times x times x times x. So again, we have 3 x's for x cubed and 5 x's for x to the 5th. So we have a total of x to the 8th power. Eight's not showing up so well. It's x to the 8th. Alright, in the next example, we have 2 different things going on. We have an x and a y. So I'm going to color code that. So I'm going to make my x's red. So I have 1, 2, 3 x's for x cubed. And then I'm going to have 2 y's for y squared. We then have another x, and then 2 more y's for y squared. So I'm taking the number that is the exponent, so like 3. So for the x, I have 3 x's. And then for the y's, we're going to have 4 because we have 2 y's in the first part and then 2 y's in the second part. So when we go to write this, we're going to have x to the 4th power, and we're going to have y to the 4th power since there are 4 y's. For the next example, I'm going to do the same thing. I'm going to color code it. So I'm going to make my 7s, I'm going to leave that in the black ink. So we have 7 times 7 for 7 squared. And then we have x times x times x for x cubed. We have another 7. And then we have x times x. So I have 7 to the 3rd power because there are 3 7s. And then we'll have x to the 5th power because there are a total of 5 x's. Alright, and then the final example. So we're going to have a 2. We're going to have x times x times x times x for the 4 x's. We're going to multiply by 3, another x, and then y times y. So we're going to take 2 times 3, which is going to give us 6. And then we'll count up our x's. So we're going to have x to the 5th power, because there are 5 x's, and y squared. Before we move on to the next page, we're going to look at 3a. So when you multiply, the order of factors does not matter. That means that you will get the same answer if you multiply 3 times 2 times 3, and if you multiply 2 times 3 times 3. This is the commutative property of multiplication. So we want to check that 2 times 10, so 2 times 10 is equal to 10 times 2. So if we take 2 times 10, we get 20. 10 times 2 is 20, so that works out. They're equal. Is it also true that 2 divided by 10 is equal to 10 divided by 2? Well, this is going to not be true, because 10 divided by 2 is going to equal 5, and 2 divided by 10 is going to equal 1/5. So these are not equal. So for number 8, we're looking at when we take a number raised to a power, and then raised to a power again. So we are going to look at this first one that's not done for us, which is 2 squared then to the 4th power. So this is the same thing as saying 2 times 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 2. So we have the 2 times 2 in parentheses 4 times. So if we calculate all of those 2's, that's going to be 2 to the 8th power. So the next one, we're going to have 3 to the 7th, and then we're going to square that. So we'll have 1, 2, 3, 4, 5, 6, 7 3's that are being multiplied together in a parenthesis, and then 7 more 3's. So we will have a total of 3 to the 14th power. There should be 14 3's. Next one, we have x cubed to the 5th, so we'll have x times x times x, in a parentheses 5 times. I'm going to run out of space. So that's going to give us x to the 15th power. The last one here, we have 2 different variables, so we're going to have the x times y, x times x times x, y times y, and then x times x times x, y times y. So we will have x to the 6th power and y to the 4th power. So we want to describe the pattern between the exponents in the original form and the exponents in the simplified exponent form. So hopefully you're noticing that there is a connection. So if you take a look at the exponents, the 2 and the 5, and we're going to get 10. The next one, 2 and 4 with an 8. 7 and 2 with the exponent of 14. 3 and 5, exponent of 15. I hope that at this point that you can see that the 2 exponents are going to get multiplied together. And the same thing happens in the last one. We're going to take 3 times 2 to get 6, 2 times 2 to get 4. So when you have a power to a power, the exponents are going to get multiplied. So in part B, we're going to visualize 20 to the 3rd power raised to the 8th power written in factored form. So our base is going to be our 20, and then how many times is it multiplied? Well, we're going to take the 3 and we're going to multiply with the 8, so it's going to be 24 times. So if we rewrite the expression in simplified exponential form, it's going to be 20 to the 24th power. In number 10, we are going to look at simplifying when we are dividing. And we are going to talk about something called the giant one, which you may or may not have heard of back in middle school or the previous class that you took. So we're going to write out the factored form. So we're going to have 5 times 5 times 5 times 5 times 5 times 5 times 5 over 5 times 5 times 5. So we have 7 5s on the top and we have 3 on the bottom. So we are going to box in any giant ones. So if you recall, that just means that whatever's on the top and the bottom, that's going to become the giant one. So those, and those are going to simplify to just be 1. So we are left with 5 times 5 times 5 times 5. So we can rewrite that as 5 to the 4th power. So we're going to take a look at number 11, which has a chart, and we're going to factor it out and then write the simplified exponential form. So in the first one, we have 2 to the 4th over 2 squared. So that's 2 times 2 times 2 times 2 over 2 times 2. So if we simplify, make the giant 1, we're going to be left with 2 squared left over. In the next problem, the same kind of idea. We're going to have 3 times 3 times 3 times 3 over 3 times 3 times 3 times 3 times 3. We're going to make the giant 1, or simplify what we can. And this time we have a 3 that's left over, but notice that it's in the denominator. So we are going to write this as 1 over 3. So if it is in the denominator, it will stay there. So now we have 7 times 7 times 7 over 7 times 7 times 7. We simplify all those, and everything gets simplified to just be 1. Y to the 7th, so we're going to have 1, 2, 3, 4, 5, 6, 7 y's over y to the 4th, that's 4 y's. We're going to simplify 1, 2, 3, 4 y's, so we have 3 y's left over, and they are in the numerator, so they're going to stay in the numerator as y cubed. In the next problem, we are going to throw in a coefficient. So we are going to take that 4 and we are going to divide it by 8 like we normally would. So 4 divided by 8 is going to reduce to 1 over 2, 1/2. So we have 1 times x times x times x in the numerator over 2 times x times x. And now we can simplify our variables, so we are left with 1x divided by 2. In the next one, we have x cubed, so x times x times x, times y squared, which is y times y, divided by x times y times y. So again, we're simplifying what we can, and we have 2 x's that are left over that are in the numerator, so it's going to just be x squared. Final problem, we have x times x times x times y over 5x's and 5y's. 1, 2, 3, 4, 5. So we're going to simplify what we can. So 3 of the x's can simplify and 1 of the y's. So we're left with 2 x's on the bottom, so that's x squared. And we're left with 4 y's that are also in the bottom, so that's going to be y to the 4th power. So anytime you have a variable that's left over that is in the denominator, it will stay in the denominator.